We have a final task that is a mandatory requirement for each one and one of us to get the certification. And we want to ask you, and I'll send you again the link today. Or tomorrow, I'll send it with our ending mail of this after this session. We want to ask you, each one and one of you, to please go into the link, go into the Google Slides document, add one page describing your name, including your name, your picture, and please tell us what are your main key takeaways from this course and what would you do tomorrow morning? Not what you did yesterday and not what you believe in and did already last year or last week, but what did you not yet do and you will now perform because of what you have learned. In order to prepare this task in the best way, we must go through all the sessions, remember what there was in it, what we liked, what we didn't like, how we understand it now when we look at it again. And that will give us the perfect setting, deepness, understanding in order to have new aha moments and to see what we can take and what we want to take from this course. So this is the task. If anyone has questions, please address me, please contact me. You know my mail, you know my WhatsApp. If anyone wants to meet me on Zoom in between, I'm here to help. We will be asking you to present your slide, half a minute or a minute. We'll see how many people we have. Just saying the main points, you don't have to go through everything, but giving the main points in your voice. People that feel uncomfortable with speaking loud, that's okay. Just write to me and we will show your slide, but you won't be speaking, that is fine. Also, people that have a problem and cannot attend at the last meeting, please prepare the materials, please include them, and again, update me so we know it. The slides will be on alphabetical order, first name first, last name after. So Anahit will be before Vincent, and I will be in between because my name is Maria, etc., etc. These are the instructions, the guides. Next week, I won't be able to join because I will be speaking in Vienna in a KM conference. So Olga, our friend, will be hosting the meeting, and she will be facilitating, and the leader will be speaking will be Arthur Shelley, who many of you I hope know. And that's it meantime. So I think we can now introduce our special guest. And Vincent, I can't help myself. You asked for it. I'm asking you to introduce our dear friend Art.
Okay.
Please go.
Great, thank you, Maria. Well, I mean, it's a great pleasure and a great honor to have Art Murray with us today. And I've been knowing Art for many, many years. Yes, almost 30 years or even more. I was telling Maria early on that when I started my PhD in knowledge management at George Washington University in 1999, the first class I took was with Art Murray, and he's the one who introduced me to the core concept of knowledge management, which was still the early days of knowledge management. And from that class and from that semester, then I decided to move into that direction and never left the knowledge management. And so I'm very lucky and very thankful that our road crossed Art. And Art has been also the first managing director of the Institute for Knowledge and Innovation at George Washington University. And later on also, that's why when I moved to Bangkok University 17 years ago, I created a branch of the Institute for Southeast Asia. So so we have been in touch with Art since then. And we also, with Moria, we led a course a few years back also on AI and knowledge management. Some of you may have attended this class. So I mean, Art is still very, very active, working on many projects related to to AI, so we could not get a better speaker today to talk to us about how AI can be used to help and support the elicitation of tacit knowledge. So Art, the screen is yours, and again, delighted to have you among us. Thank you.
All right, thank you, Vincent, for that very fine introduction. And yes, you brought back some memories of our early days at George Washington University. And yes, we were kind of back in the late 1990s, as they say, we are building the airplane as we are flying it. And I think in the early days of knowledge management, that is kind of what we were doing. But we all kind of gathered together at that institute in the early days, the early formation of that institute, which is still around. And we've been going strong ever since. So it was great having you, and our dear late friend, Dr. Frank Calabrese, was also part of that first class. And yes, it was amazing. And now we get to reflect back on, as we were talking before the meeting began, in the early days, George Washington University's knowledge management program really came out of the AI program. But at that time, we began AI in the early 1980s. But it had kind of reached its maximum, we did not have the computing power. So we then morphed into knowledge management. And now that Moore's law has caught up, and you see AI, generative AI especially, has taken the world by storm, I think it's the perfect time now to combine the two. And I know that's what this course is doing, combining knowledge management, and especially the difficult area of tacit knowledge management, and using AI and machine learning as tools to help further enable the capturing and creation and gaining value from tacit knowledge. So it's great to be with you. I see many people from many different countries here this morning and this afternoon, this evening, wherever you are. So welcome everyone, and let's get started. Great to be here. So here are the different pieces we'll be looking at, and I guarantee you some of these items, I hope, are something new that you haven't heard anywhere else before. That's what we try to do. And so, of course, tacit knowledge is our main target. And we want to take tacit knowledge and make it explicit. All right, that's fine. But there's other things that we sometimes forget along the way. And one of them is implicit knowledge. Very often, implicit knowledge, which is sometimes and often exhibited in our behaviors or in the actions that the human experts take. Remember, tacit knowledge is very deep and very difficult to draw out, and even more difficult to express explicitly. But we often forget that there's this implicit step in between where people sort of know what they're doing. They're not necessarily expressing it explicitly, but we can observe their behaviors and then from that draw out the additional tacit knowledge that's behind their actions and try to make that explicit. So that's the number one thing I'd like to impart today is let's not forget implicit knowledge as a possible bridge between tacit knowledge and explicit. Then the tools, AI/ML, as the course title says, but another tool I think that we also is becoming very important lately is knowledge graphs. And I'll show you how to incorporate knowledge graphs, combine them with AI and machine learning to produce a much better result. And then there's one more piece, which again, I hope is something that maybe we can think more about that we haven't thought enough about, and that is AI and machine learning use what's called deep learning. But deep learning, back in the early days that Vincent and I were talking about in the 1980s in the AI lab, deep learning was actually patterned after human learning models. So I think we also need to go back and reflect a little bit. Now that we're talking about machine learning as deep learning, let's go back and say, let's not forget that humans were doing deep learning long before the machines ever were. So there's this, that sets the table. I hope it'll be a very exciting session for you. So we have the humans on one side, the machines on the other, and we want to set up a learning loop, right? A double loop learning, maybe even triple loop learning, where humans teach machines and machines teach humans. And together, we accomplish much more than either one could alone. That is really our goal here. So let's get into it. So our main purpose for this particular module is to understand how to leverage the value creation of tacit knowledge. And by using AI and machine learning, but then also let's add this new thing called knowledge graphs and show how much more powerful our knowledge extraction, especially the capturing of tacit knowledge, can become. And we can reveal more tacit knowledge using knowledge graphs as a tool in combination with AI and machine learning. Does that make sense? Okay. So our agenda will have 3 steps. Number 1, just a quick overview. We should understand the attributes and limits of both human and machine intelligence, and then know the right way to use AI and machine learning so we can gain new insights and knowledge from deeply hidden, tacit, implicit, and explicit knowledge. The funny thing, and maybe it'll be something to give you something else to think about, is even though we may have explicit knowledge, there could be tacit knowledge hiding within it. Now, you'll see what I mean by that in a little bit. And a special bonus module, how much, enough technology evolution already. What about us humans? If we are going to have this blend of human and machine intelligence, we ought to be looking at, because technology evolution is racing along, what can we do on the human side to expand our awareness and our capacities so that we can at least catch up with the machines, that we won't be taken over. So there's a special bonus module at the end. We'll reserve some time at the end for that thought, because I think that's very important in putting it all together. And finally, we'll be doing one survey question, and that's on menti.com. So you can take this, it'll come later on, a little bit later, but if you can, in the background, log on to menti.com. And maybe you can write this number down. The number will appear again when we go to that survey question, but this is the number. So if you go to menti.com, it'll ask you to enter in the code, and this 8-digit code, 79803415, that's the code you enter when you arrive at menti.com. And then you don't need to worry about anything. We will pick it up from there later, but I just wanted to alert you so you can have menti.com queued up somewhere on your machines. All right, let's go on. Know the attributes and limits of human and machine intelligence. All right, story time. This is just a fun story. Recently, you're familiar with Midjourney AI. When Midjourney AI first started, came out, this was a few years ago already, for fun, we asked it, please draw yourself, because you can ask Midjourney AI to draw anything, and it'll draw it. So we said, draw yourself. And this is what came back. And we were sort of having fun with it. We started talking about it online among ourselves, and we said, wow, this is really intelligent. And especially this second image kind of indicates that the AI knows itself. It sees itself, right? It kind of says, I'm self-aware. And so we got very excited about that. And a day later, one of our group asked the same question to Midjourney AI, please draw yourself. And this came back. And asked again, and this came back. And so our imaginations really ran wild and said, wow, do you think that the Midjourney AI thought that it told us a little bit too much? And now instead of showing that it knows itself, it's giving us a blank screen instead as an image of itself. So that's just a fun story of where we can go. But generative AI has certainly taken the world by storm and has caused a lot of excitement. But let's go back to a moment to this humans and machines notion. Don't forget what we humans have a lot of great capacities. Their human neurophysiology is a marvelous, marvelous creation, correct? And we have intuition, insight, foresight, and we can experience, not just maybe, you can program behaviors into a machine so it begins to act human-like, but the machine is not actually experiencing those emotions and biases and traits that we humans do. We actually experience that. So all of that combines for a very powerful way to observe the world and make inferences and learn about the world and then make judgments and even create some foresight about where we might be headed. The machines, purely computational. Now quantum computing is getting a little bit different, but for now, all of our computation is von Neumann, zeros and ones, digital. You can put dictionaries in computers, but they do not understand meaning, purpose, and intent. And they certainly can't formulate evocative questions. Like Einstein was thinking about his theories, and he asked the question, like to ride on a beam of light. And that question led to the theory of general relativity. Well, you won't find a computer thinking about, what is it like to ride on a beam of light? That is purely human. But don't forget, machines blow us away. We know we've exceeded the human capacity for computation. So again, let's think of how humans can teach machines, and humans can learn from machines. But we should have this governance, and we won't get into that. That is a whole separate topic. But I wanted to mention that because, again, the more we put into and the more we depend upon machines, we should have a system of governance in place to help manage this process. But again, the result, better than either one alone, humans and machines working together. All right, so that sets the table. So not humans versus machines, right? Not humans versus machines, humans and machines. Okay, so let's go on to the next part right away. This is the meat of today's session, and that is knowing the right way to use AI and machine learning, that we can gain insights and knowledge from hidden, tacit, implicit, and explicit knowledge. All right, we're drowning in data and starved for knowledge. Data, 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 data. Everything you hear, data analytics, it's crazy. And by next year, the projection is 175 zettabytes of data out there on the internet. Now, a zettabyte is a trillion gigabytes. So we're talking 175 trillion gigabytes of data. That is massive. That is almost insane, all right? But that's the generative AI part, which relies on induction, all right? Wanted to contrast that with the knowledge in the human mind, and that we have built up over centuries of acquiring and deriving knowledge through our theories and abductive inference and experimentation, from which we then use extractive AI to write the rules, the axioms, right, and the inference algorithms to do knowledge-driven exercises by deduction. Okay, so the generative AI is using induction, and human AI and extractive knowledge-driven AI is using deduction. But right now there's a very serious imbalance because this is where all of the intention has been going. So how can we restore this balance? We'll get into that. But there's something called the fallacy induction, which I think is very important for us to know in this crazy time of generative AI. You know, generative AI makes things up many times. And Bertrand Russell, philosopher, said there are two kinds of reasoning, deductive and bad. So that's kind of a joke. But for instance, there's so much that here, this you might recognize as the deep undersea vehicle that was searching down at the Titanic, and it imploded, all right? People perished in that undersea submersible vehicle. It was meticulously designed using computer-aided design and engineering, using data analytics. It was a very, very digitally developed craft, and yet it imploded. Why? Why did that disaster occur? Well, going back to deductive inference, PV equals nRT. That is a basic fundamental rule of physics and chemistry. Pressure times volume equals the number of moles in a container times the constant R times its temperature. And so they should have known that with that simple equation, that on the edges, there were weak points that would have caused this implosion. There's another example here in the USA, southern USA, last year sometime, not too long ago, 18,000 cows in a dairy farm died in an explosion. There was a tremendous explosion killing 18,000 dairy cows. It was a dairy farm. Why did that happen? And our environmental administration and our government forced every dairy farm to to produce these lagoons, which captured the methane from the cow waste and processed it. Now, that was fine for small farms, but again, as it was applied across the board, the law said every farm had to have it. So these big dairy farms employed those lagoons to process the methane. But again, PVNRT, as the volume of methane under tremendous pressure for the larger farms built up, the tiniest spark, kaboom. So again, people were using what they thought was very good logic, and by forgetting a simple law of physics and chemistry, we had another disaster. I think no people were hurt, but 18,000 cows were killed in there. So we say, all right, so now what? Here's an interesting thought you might have heard or might not have heard. Some people are saying that in a couple of years, we'll run out of data. In other words, we'll have all the data accessed and ingested in these open AI systems that we can possibly have. Okay, then what? So that's just that's a rhetorical question. So before we go on, now it's time to go to our menti.com. I hope everybody has it up, and enter this code, and you'll see this question up there, and it's an open-ended question. So we won't go through everybody's answers, but it'll be interesting just to gather that. And then what I will do is I will summarize. We'll take a quick look at what people are responding, but I'll summarize everybody's answers, and I will send that out to everyone later at the end of this presentation. So here's one question for everyone, and enter that in menti.com. An open-ended question. What do you think is a good source, one good source for generative AI machine learning enabled tacit knowledge capture? Okay. And let me go over.
Can you explain the question? We understand every word, but altogether it's a bit complicated. So go with us through it, please.
Sure. All I'm saying is using generative AI and machine learning, those are the tools. We want to use them to capture and add value for captured tacit knowledge. What would be the best source? What do you think is the best source? And you see 3 responses have come in already. People are saying interview transcripts, and that's good because we're going to use things like conversations. Yes, these are good answers, right? So sources of tacit knowledge that we can draw from by using generative AI and machine learning. Okay, good. I think people are getting it now. Can you see the screen? The answers popping up on the screen?
Yes.
Meeting transcripts, GeoActive Group, tech target. That might be something worth explaining. Capturing user journey in platforms. Okay, so this is coming up. Text written by experts. This is good. I am glad to see this one, text written by experts, because that is something I think a lot of people are overlooking. They're trying to tap what's in people's minds, but we put out mountains, tons of written material where there's tacit knowledge hidden within that. So whoever wrote text written by experts, very good. And these others are, of course, also well-known: storytelling, conversations, expert interviews, medical reports. Yes, you can get tacit knowledge from large volumes of data, both structured and unstructured data. Emails, yes, excellent. You will see an example later on of how we used emails to find problems that could have avoided the types of disasters we just talked about a minute ago. Now let's see here if I can, is this scrolling? I don't see it scrolling. All right. So anyway, I think we'll get the idea. Like I said, I will assemble these responses from all of you. Thank you very much. And yeah, I don't know why I'm not able to scroll down. It looks like there are more answers, but I will be able to download everyone's answers collectively, and I will send them out and group them together. You might, do you see a possibility where you are of selecting your favorite? Because I think that feature should be on here. And if you see that, maybe also vote for your favorite. I don't see it on mine, so I won't worry about it. But these are good responses, and I'll send them out to you. All right, so let me get back to the presentation. But some of you have very nicely indicated hints of where we're going with this. Like I said, I hope I'm showing you things you haven't seen before. So sources, here are main sources of tacit knowledge. Of course, we know about agents, using agency. Humans, right? So what's in humans' minds? Automated agents now, because machine learning is gathering and accumulating so much knowledge, much of that ends up being hidden. We need to draw that out. And even within organizations, teams have their knowledge. If you watch how teams perform, you get to the point, a well-knit team, they'll be able to sort of, as they say, read each other's minds. They can tell what each other's thinking about or talk without even saying any words, right? They get so together on what they're doing. So tacit knowledge is in both human sources, automated sources, and organizational agents. They perform activities. Now, these activities can provide hints of hidden knowledge, and that's where the implicit knowledge, a lot of implicit knowledge can be drawn from activities, which then result in the production of artifacts. And this is where our explicit knowledge is. So this cycle came from, and this is a good source you see here in the lower right of the screen, Holsapel's book, Handbook on Knowledge Management. It's 20 years old now, but let's not throw away the old knowledge from the old knowledge management days. It's Vincent and I were talking about. So back then we said agents perform activities to produce artifacts, knowledge artifacts. But all three of these are sources of knowledge. Okay? So far, so good? So let's look at sources of, and you've recognized some of these. Some of you mentioned these. We're going to look at three. Knowledge that's deeply hidden in documents and data, hidden in discourse or conversation. Some of you actually put that in your survey response. Very good. And then observable behaviors. And that's more where we're getting at the implicit knowledge and how do we draw tacit knowledge from observing behaviors and what's implicit behaviors are going on. So let's start with documents and data. This is just a rhetorical question, not a survey question, but just a thought question. How many internal documents does your organization have? Now, notice I'm saying internal because generative AI, that's taking in the documents in the whole world, right? And ingesting everything it can find on the internet. And we know there are problems with that. But think about how many internal documents you have in your organization and how much of that content is useful. And we're pretty sure that a lot of the information we generate on a day-to-day basis is not quite useful. It's garbage, but we want to lift out the golden nuggets from all of that garbage. How much of that content is actually known and used, and then having known, starting with our internal content, now can we go to the external world and what can we find outside of our organization that can be useful? And then how much knowledge from all this available content are we able to capture and apply? And now we're getting back to the tools of AI, machine learning, and you'll soon see knowledge graphs that help us get a better ability to manage this 175 trillion gigabytes of data and information. That's a lot. So generative AI, think of when we use generative AI now, those models are available to a great extent. Google makes some of their models available. Microsoft, OpenAI does. They started more open, but you can still access some of the models and make small learning models from them, okay? So you can take them and instead of exposing, because we know when we use the generative AI, the large language models that are publicly available, our data can leak out into the public because it becomes part of the big knowledge base. So extracting those, using some of those modules as small language models in our own organization so we can run our internal, maybe proprietary documents, confidential documents through there along with our data. We can ingest those in a small language model, generative AI, and query that. So that's first step. Think of going from the large language model, which has both problems with making up information and hallucinations and all of that, as well as leaking our confidential information back out in places where we might not want it to go. Think of small language model AI. And then, of course, RAG, R-A-G, and I think you know about this, right? The response generation, response activated generation. So we can refine our queries, okay? So we can get better queries and get better information out of that. So that's we know that. So let's go and remember I said we're going to combine generative and extractive AI. So let's look at the extractive AI side. In extractive AI, we use text analytics. We use feature extraction using text and data analytics, entity association extraction, but built upon a layered reference ontology. The ontology gives the machine, gives the AI the semantics. Remember, generative AI doesn't use semantics so much. It just uses whatever it finds in proximity to the keyword you enter. And ChatGPT is just one direction. It's everything following that word. And BERT, which is Google's, is bidirectional encoded representation for transformers. It goes both directions, but still, what's more important, what's missing is the machine understanding. That's why sometimes you get silly answers back from generative AI, because it doesn't understand. It doesn't have that machine understanding of the semantics and the meaning of the terminologies used in different domains. So this is important. And we have built this, and there are reference ontologies available. SUMO, suggested upper merged ontology, SUMO, you can see that there are very tiny letters, is an open source ontology that's the largest in the world right now. So now we take the entity association extraction and build a knowledge graph. This is sometimes, like we call it, a digital hairball, but it is a visual representation of all the concepts and the associations, right? The entities and associations in this collection of documents and data represented visually. And here's the other part. Now that you do this, you can have subject matter experts review the output of this engine, and this is AI, but it's more extractive AI, and then refine the ontology. And here's a learning loop, an ongoing learning loop, where this entity association extraction, the text and data analytics, can become better and more refined as we go along. Now, having done that, you can query the knowledge graph. And the difference between a graph database and a relational database, as you know, if you wanted to find the relation between, let's say, this dot here and this dot all the way on the other end, in a relational database with the table joins, it could take hours and even days of computer crunching. In a graph database, because it's queryless and it's real-time query, schemaless, zip, it can find those connections in seconds. So it's a very powerful tool. So that's where extractive AI comes in, drawing knowledge from large volumes of documents and data. Okay, so now combine the two, we simply add the generative AI and the RAG module to this architecture. And here's the complete architecture for combining generative and extractive AI for extracting knowledge from large volumes of documents. Okay, that's the documents part. And some of you also mentioned conversation. So let's look at the same technology. Take relevant documents and data and then add. So we still want to keep the document part. So we should do the documents first. Now let's go, because we have a foundation to build upon. Let's look and see what people are talking about in, whether it be interviews, conversations, emails, text messages. All of that discourse now can be captured, just as this Zoom session, right, is capturing a transcript, right? So we can take the transcript of this Zoom session, right, ingest it into the text analytics engine, and then query what was said during this Zoom session. Okay, we might try that for fun afterward. All right. So that adds the discourse in there. So let's do it. Let's give you an example of what can be drawn. Entities and associations, the text analytics tools that are out there can produce dozens of categories, but thousands of entities in this digital hairball and connections between the entities, whether it's subject, predicate, object, or subject, process, object, or if you're familiar with RDF, right? Semantic triples. This is a semantic triple. A relationship B, right? Very simple construct, but that is all present in this text entity extraction. And there are hundreds of these relationships that can be grabbed. The other interesting thing about using analytics, text analytics, is we can now measure sentiment, not only what's being talked about, but with what emotions. Remember, I said humans speak with emotions. And here's where we can get a lot of tacit knowledge. So right now, the vectors that we use in our work are salience. That's the degree of importance, and that's a scale of 10 to 100. Polarity. How opposite? What are the oppositional scales? Because something here may be totally opposite to something over here. So that polarity is measured for every pair of associations. Aspect. This is interesting because somebody could say this is very important, but it's not front and center. It is hidden in the back. That's a contradiction. We want to be able to use analytics to pick out things like that. If you say it's important, does it have a high aspect? Or if you say it's important, does it have a low aspect? Or are you wasting energy saying this is not important, but has a very high aspect, and we're wasting entropy on it? Does that make sense? The intensity, with what intensity are these topics, items, categories being discussed on a scale of 0 to 3, and then with what mood, from extremely negative to an extremely positive sentiment, okay? So these are available with the tools we have today. They're very good for drawing out meaning from tacit knowledge. And of course, you can use this. You can ingest what a person, an expert, has written and get these indicators, and then use these indicators to then follow up with that expert with additional questions in an interview, getting at that hidden tacit knowledge that is so difficult to draw from, okay? And we can also use these in other approaches, which we've been using them as flags. So, when we can find, is there a problem that might result in a disaster? Can we detect those problems early? And using these sentiment indicators, we have done that. And I can give you an example of that. Connections. There are hundreds of connections, even thousands of connections. These are just examples of a few. But again, by ingesting everything that's talked about, the discourse, the documents, I can see who manages who, what the cause of something is, what failed, what worked, where's the money, right? And then they say, if you want to solve a problem, follow the money. Okay, we can follow the money. We can see where people are in proximity to each other, geographic proximity, temporal proximity. How close are they related to each other in time? It's virtually limitless. And of course, we're going to need machines to do all of this. This is too much for a human to keep track of. And this is just a small sample of the extraction, the entity relationship extractions that are done by these tools. So let's go back to one more example. This is the airline disaster. You're probably familiar with the Boeing 737 MAX aircraft. Again, a highly sophisticated aircraft designed totally by computer. Boeing bragged about how they used their computers to design this perfect aircraft. And as you know, it crashed. And so what we did, we took Boeing's, all the specifications and standards they were supposed to adhere to, and we were able to obtain their internal emails on that project over an 18-month period. And we also ingested NASA, the US Space Agency. They have a very good collection of lessons learned, right? And knowledge, because they had some disasters. NASA has had space disasters where people died, but they learned from it. So we want to grab that knowledge, bounce it against the internal emails, and see what comes out using this architecture. Now, we did not use generative AI for this example. We just used extractive AI. But here's an example of what we got. On the NASA documents, this particular report, we found that risk was received the highest amount of importance. And you see green because risk was treated very favorably, very positively. NASA, the organization themselves, the authors of the report, they think very highly of their organization. That's okay. And safety, of course, was the third highest ranked topic in terms of salience and importance, all treated positive. What about those Boeing internal emails over an 18-month period? Well, Boeing thought of themselves very highly, as you should. Every organization naturally should think highly of themselves. But risk was also very high in importance, but ranked red. Okay, they treated risk negatively. That's very interesting. And you'll see the reason for those crashes, Boeing tried to avoid oversight from the regulatory agencies. They saw risk, but they tried to avoid it. It was treated negatively. And when it comes to safety, well, how did Boeing treat safety in their discourse over 18 months? Not once. Safety. In all the Boeing documents we ingested, safety was never. Now, I'm not picking him. It's easy to pick on Boeing because, you know, they're famous. This is front page news still. But I want you to think of this not so much for Boeing, but for any organization. What I have here in the title, what is missing? You can use this AI, machine learning, text analytics, knowledge graphs to not only find out where the strengths and weaknesses are, where the positives and negatives are, but you can also find out what's missing. And you say, wow, we're building passenger airplanes and nobody mentions safety. That should set off an alarm. So that's, I said, I use this as an example for you. Okay.
And then, can you go back to it?
Yes.
I think that when we are speaking this course, first of all, amazing example. Because when we speak about the theory, everything looks okay. But when you come to the example, it shouts out. But I think that on the methodology level, we can learn here two things where tacit knowledge can be unveiled using the machines. We can see here both the idea of sentiment, which was not spoken and maybe not even noticed because it went between the lines and it was not documented because it's sentiment, it's something in the air. And two, the idea of text that is not included as safety or included in lower levels. So these are two tacit examples of one, sentiment, and two, missing content or low-level content, two examples of how tacit knowledge can be unveiled using extractive AI.
Yes, thank you. That's perfect, expressed perfectly, Moriah. Yes, excellent. That's exactly right. And yeah, and sometimes tacit knowledge is hidden because people are afraid. They simply won't, they know it, but they're not going to reveal it. So that's also an interesting aspect of this. But 2 points, if you have a rich enough document collection, we discovered these shortfalls by comparing the Boeing work with the large body of work we obtained from NASA. And so the two combined helped reveal gaps on the Boeing side, because NASA did a great amount of extensive work. Okay, so that's good. And then the other point is in knowledge graphs, remember I mentioned the ontology. So the underlying ontology has to be very rich so that these hidden meanings and connections can be revealed. If the ontology is very thin, you won't get the richness of these connections. So all of that is very good. Yes.
Okay, now before you continue, there's a question here of Dave. Could you please provide example of sentiment that combines two different metrics in a matrix? That is one that is a question, and then there's also a comment from Kim, but one by one.
Yes, the first question is good. I personally like to break out these into components, but one of the tools we use combines these different elements of sentiment into a single vector or a single value. So yes, they call it sentiment. So you can do it. You can aggregate these if you want, because it does get very complicated and very deep. I like it, especially if you're doing investigative work. If you're trying to dig deep, then I prefer, my own personal preference is to break out each of these different elements. But if you're just looking, like if you're a marketing person, you just want to say, hey, are people looking at me positively or negatively? Then yes, you can aggregate these, or even you can select, just say mood and just pick one of those. So yes, you do have flexibility into how to apply sentiment to text analytics. Okay, well, there was another question?
Oh, it wasn't a question. It was more a comment saying, giving another example of a scandal and saying that it would be fascinating to learn what happened there. But you can, I'm not sure you have to respond to that. And Noga is asking if ontologies could be concluded by AI.
Could be concluded?
I think that can you learn what the ontology is using AI? And of course, we spoke a lot about unsupervised unsupervised machine learning. So you can speak about that. Please, you answer it. I won't answer the question. Please, you answer it.
Yeah. Well, again, when you're using unsupervised AI, it's like a black box. Ontology gives you the ability to introduce semantics so that the interpretation of the input data is more accurate. All right. So that their semantic meaning is taken into account. You can use them both. Yes. Earlier, I don't want to go back to that earlier slide, but remember where we had the subject matter experts and there was that learning loop. So the AI will generate this knowledge graph. The experts will look at it and say, "Ooh, it's misinterpreting this," and then the expert will update the ontology. So the AI can present or identify weaknesses in the ontology, which can then be strengthened, right? Or, as has also happened in some cases, the humans discovered things that the AI missed. So AI would find things the humans miss, and humans find things the AI miss. So my overall comment there is keeping in mind that theme: humans and machines working together, teaching each other, and together you keep growing the knowledge base, tacit, implicit, and explicit. Does that make sense?
But you didn't. Yes, but you didn't answer the question. The question was, can the AI help me in building the ontology, in driving what should be my ontology on this topic?
I think just from my own experience is the visualization helps me understand ontology better. Because ontology, if you look at OWL, web ontology language, it is very hard to understand. So I don't know if I understand your question, but for me personally, yes, some ontology is extremely hard to understand, especially the standards like OWL, OWL, right? Web ontology. When you visualize it as a knowledge graph, that allows you to better understand it. Is that getting closer to what you're asking?
Noga, does it answer your question?
Yes,
I would give a different answer, but wonderful.
I got it. Okay, thank you.
Wonderful. And now there's okay. Please continue, Art. Yes.
Okay. All right. Oh, so one more thing. So remember I mentioned that knowledge graph databases can very quickly find something. So I have this risk, and I want to say Boeing thinks the risk is negative. NASA thinks of it as positive. Here's risk. Here's the risk node. 3 hops away, okay, I've identified a NASA document that talks about risk, and it has a possible solution for us, risk-informed design. So I hover over this node. This is an actual piece of software, and it gives me a little snippet. If I were to drill down, then I can go into the documentation more detail and identify and learn from NASA. What did they do when they had risk-informed design, okay, on these programs? And maybe that could help me move from treating risk as something negative to something positive. So again, The graph database and the knowledge graph allows me to zing very quickly, answer queries and get the knowledge, the missing knowledge, because there's a lot of valuable knowledge in this NASA collection about risk, right, and mitigating risk, but it would be buried. It would, if you tried to do this with a text search, just a standard search tool, you might not have found that document. So that's the power of graph databases and knowledge graphs. Okay. All right, want to move on. One more, behaviors. Yes, behaviors. I don't want to take, I want to, don't want to go over time. There are behavior cues that we can look for as we're observing experts performing, or even in sports or whatever our domain is. And I'm going to just have to leave you with this slide. I won't be able to go through everything, but there's a range. Is one aware of their own mental model? If we're trying to extract tacit knowledge from somebody, how aware are they of their own mental models? Are they fully aware or totally unaware? What perspective are they coming from? And that's where sentiment comes into play a lot. And then there are others. What are a person's powers of observation, expression, right? Expression, olfactory and gustatory, right? You're familiar with VAKOG, V-A-K-O-G. These are the 5 senses: visual, audio, kinesthetic, olfactory, and gustatory, right? Taste, so sight, sound, touch, smell, and taste. Okay, those are great ways to draw out tacit knowledge. So I'll leave you this. We won't go through this. This will be part of your handouts. It's a very good handy-dandy list of things to look for when you're trying to draw tacit knowledge, especially from human experts. But don't forget, now that we have AI, how well is the knowledge representation? So it's not just humans now. If I want to extract, if my AI system, a machine learning system, has extracted knowledge from thousands of documents, how do I find missing information? Well, how it represents knowledge is a good way. How it expresses that knowledge in terms of its output language. And you'll find that generative AI, the language coming out of there is very simplistic. It's not very professional, okay? So this list should help you in diving deeper in the extraction of knowledge from both humans and machines. So I have to go on because I don't want to take up too much. Oh, another way,
And we are
example of
ending in a minute or two.
okay, behaviors, blank paper tests. When you force people to write, you can then see how timid are they, how dominant is it. They use colors. So we've used this in school, in mathematics classes. We've used this. Quick story. The analytics said this golfer, this is the right way to do it. You should flex your knees and keep your eyes straight down on the ball. But the best putter in all of golf, he's a legend, he does the opposite, you see? His knees are stiff. And he says, no, I keep my knees stiff. So the whole conventional wisdom and analytics says, keep your legs flexible and your neck stiff. He says, and he's the best, the very best putter in golf, says, I do the opposite. So, but he's the best. So here again, know when to separate the natural from the artificial. He does everything naturally and it works. These people try to do everything using analytics and it doesn't work. And there's the same thing. There's the best pitcher in baseball. Analytics says, here's how you hold the ball. But his coach noticed that he was holding it differently. And as a result, his balls cut to the side. It was called a cutter, okay? And hitters couldn't hit it. The batters could not hit that ball. And now that they discovered this by accident, every pitcher now includes the cutter. All right, I'm going to have to wrap up. My bonus module was how do we expand our own awareness? Because we're diving into data. So simply, if you consider knowledge as a subject, an object, and a process of observation, okay? Subject, process, object. Typically, here's our view. Here's our perspective. I look at an object or I observe an object. That's the ego view. That's from my point of view. The other way is the empathy. The object and subject switch places. And so a person with empathy says, I want to imagine myself as walking in your shoes. Okay, that's a second perspective. Point here, mathematics says there are 6 perspectives. The third perspective is we can switch subject and process, switch. And what does that world look like? Well, that could be the process-oriented person. Everybody who thinks process, process, process. But there are 3 more transformations. So I just leave you with this to think about, and you can look at this slide, and I have an example to follow it. What happens when you stay the same, but you switch the object and process? That's a different perspective. Now you do a double switch. You switch object and process, and you switch subject and process. What does that world look like? That gives you some new information. And same way, a final transformation. So there are very often we are using 1 or 2 perspectives. We try and maybe we view things from our own perspective and we view things from the other person's side. That's 2. There are 4 more. And so my point here is try to use this as an exercise. And there's an example in knowledge management. We may be mentoring somebody. So here, just applying that same transformation to the mentoring process. You mentor somebody, but the benefit of mentoring is you can learn from the mentor. But then you learn from the process of mentoring, right? And then what happens when you switch, okay? So I'm going to have to go and leave you with that for your own thought. But when we've done this in workshops, it has really helped to expand people's awareness and perspective. And this is essential to what my point about human awareness. We need to evolve our human awareness, our human consciousness much more. And this is one way to do it. So we were imbalanced this way. We want to restore this balance of induction and deduction, generative and extractive. How do we do that? Well, we get away that one person. We have 8 billion minds on the planet. So let's draw from these 8 billion minds, in addition to the 175 trillion zettabytes of data. And one final thought. So we have, instead of devolving, let's use AI and see how we can expand our own consciousness and awareness so that together we can create a better future. Okay, that's it. Time's up. Hope that has been useful and given you some things. I hope it's given you some new things to think about that you haven't seen elsewhere. And likewise, here's some additional resources. You have these slides will be given to you. And so you see, this is probably the best place for the items that I've talked about. And then, please share your questions. Here's my contact information, or ask questions through Mariah, and Mariah can relay them to me. Connect on LinkedIn and x.com. So, all right, I'll leave that open. Back over to you, Mariah. If there are any other last-minute questions or thoughts, thank you very much for the opportunity to present this to you.
And just peek at the chat here, because everyone's saying how great it was. Bye all.
Thank you so much, Art.
Okay.
Okay.
Yes.
Thank you. Bye-bye.
All right.
Bye.
You're a wonderful
Thank
group,
you.
global group, world, all over the world. It's very exciting.
Yes, we are.
Thank you.